I'm Nasser Al-Azmi,
And I'm Duahi Al-Muteri.
and we are going to present our PowerPoint.
So our topic is smart irrigation system. Our contents is introduction, problem statement, project idea, general block diagram, motivation, hardware implementation, conclusion and benefits, future works and acknowledgement. And here the introduction. Internet of Things and automation is the goal of every engineering company, regardless it's a new started company or a large one. And these days, everything is connected to the internet, and by default, any new product will have the internet connectivity, and not as an extra feature. Most of the leading company focus on industrial side or domestic side of the automation. But in this project, as a team member, we will focus on the agricultural automation and its integration with the Internet of Things portion. And the problem statement is due to water shortage in most parts in the world, and considering that the irrigation is taking the largest part of the water usage, there is a huge need for cheap and good quality food for the increasing number of population every year. From this point, new methods should be taken into consideration when using water for irrigation. Most of the irrigation techniques depends on time and no real feedback about the soil moisture, which leads to over or under irrigation. Where in the first case the water is wasted, and the second case the planets will not take the enough water. And here is our project idea: to design and implement a hardware and a software based on an Arduino microcontroller to harvest the solar energy and probably store it in a rechargeable battery, which will be used later to energize the irrigation process in faraway places or farms. The system has an internet connectivity which will allow the user to monitor the harvest energy from the sun using the solar cells. Also to control the irrigation process in two modes. The first mode is automatic, where the irrigation will be started automatically on a low soil moisture level. And the second one is manually, where the user can start or stop the irrigation from the mobile app. And here we have the general block diagram. I'm gonna start with the solar cells down in the right. So the solar cell is connected to the power analyzer, and the power analyzer is connected to the charging circuit and the controller, which is the Arduino. So when the I'm gonna talk with when the power analyzer go to the charging circuit, and from the charging circuit it goes to the battery and the voltage regulator. So and when it goes to the controller is connected to the Wi-Fi modem and the rotation motor and the pump drinking circuit and the soil moisture sensor.
Motivation: to achieve a system that will handle the irrigation process and make it very easy for the users regardless of their agricultural knowledge. The user can use his mobile application to monitor the following values: real-time soil moisture level, real-time cell voltage, real-time transferred power from cell to system battery. Also, the user can control the following aspects in the system: water pump on or off, operation mode. And this slide, this is like the GUI system, so graphical user interfacing. As we can see up there, the three gauges. The first one is the voltage gauge and power gauge, soil moisture gauge. So the user can read all of them there. And then we have the slider, where the user can set the moisture depend on the weather or the plant he has. And then in the bottom we have two modes: the auto mode and manual mode. The auto mode, where the irrigation system will work automatically depend on the soil moisture that the user set before. And then the manual mode has two options. The first one is on, which will be on all the time, and off, which will be off all the time. Doesn't matter how the soil moisture is. And then we have the hardware requirements. As we can see in the left, the Arduino Uno, and this is the most important part of our project. Operating voltage 5 volt, flash memory 32 KB, SRAM 2 KB, EEPROM 1 KB, the clock speed 16 Hz. And the Arduino is like a small circuit which has a lot of things. For example, the programming circuit, the power circuit, reset circuit. That's why the Arduino Uno is very popular. And then we have the ESP8266 built-in micro USB with flash and reset switches, easy to program, full input-output port, and wireless 802.11 supported. And in this diagram we have the solar sensing and control circuit. As we can see in the middle, the Arduino, and the left we have the servo motor, where the servo motor will move the solar cell, and the servo motor considered as a digital device. That's why it's connected to the digital side of the Arduino. And the servo motor has three pins. The first one is the single pin signal pin, which is connected to D6, and then the second pin connected to high voltage, and then the last one is connected to the ground. And in the right side we have the LDRs. So this guy will catch where the light come from, in which direction. So I'm gonna explain how the LDR work. So when the LDR receive the light, it will convert the lights to resistance. But as we can see here, the LDR one is connected to the pin 1, and the R2 connected to the A2, and the R3 is connected to A3. And these pins are analog voltage pins, so they are only read voltage. That's why we connected 10 kilo ohm resistor and connected to the ground. So we made in this point a voltage divider. So when we have highlight in R1, so the resistance will be low, so the high voltage will go through R1 and will go to the 10 kilo ohm by voltage divider. So in this point, the A1 will read high voltage in the R1 side. So the Arduino will get this information and send it to the servo motor, and then will move the solar cell to the R1 side. And all the LDRs work in the same way. LDR, light dependent resistor.
And here we have the Wi-Fi interfacing circuit. So as we know, we are using Arduino Uno, and the Arduino Uno does not has the connectivity feature, the Wi-Fi connectivity feature. So we had to use the ESP8266, which will help us to connect to the Wi-Fi and the Internet of Things. And the ESP8266 is connected to the Arduino in pins D0 and D1. And the pins in the ESP is the RX and the TX. So the RX is mean the receiver, and the TX is the sender. So the Arduino gonna send all the command to the ESP, and the ESP gonna send it to the Wi-Fi and to the Internet of Things, the app. So this is like the job for the ESP. And here we have the power analyzer INA219. Feature this senses bus voltage from 0 to 26 voltage, reports current, voltage and power, and high accuracy. And this is a picture of it. Here we have the solar power monitoring and battery charging circuit. So I'm gonna start with the solar cells as you see in the left. So the V plus, when it goes to the power analyzer and pin 8, the V minus it goes from the pin 7 to the post converter. So the power analyzer is, as we said before, it's connected to the post converter and it's connected to the Arduino. So when it's connected to the Arduino, the SDA and the SCL is connected to pin A5 and A4. Even though they are connected to the analog side of the Arduino, they are not analog communication because it's a digital communication, and the Arduino support the digital communication in pin A5 and A4. And when it goes to the post converter, the post converter gonna make sure that we get 8.4 voltage, because we are using a lithium battery, and the lithium battery and we are using the charge controller to prevent the overcharge and the over discharge, and the charge controller need 8.4 voltage to work, to like give us the efficiency that we need. So the post converter gonna make sure that we get 8.4 voltage to charge the lithium battery, and we have the buck converter that the one gonna step down the voltage to 5 voltage. And here we have the soil moisture monitor and pump controlling circuit, and here we're gonna know how the pump the water pump how it works. So the soil moisture sensor is connected to the Arduino on the analog side. So it's connected to the A0. So the soil moisture gonna read the soil and gonna send the number to the Arduino, an analog value, and the Arduino depend on the number that it gets, and the soil moisture that we set, and the user is gonna send digital value like digital 0 or digital 1 to the FET transistor. And if it gets 1, if the Arduino send 1 digital 1 to the FET transistor, the FET transistor gonna connect the wire to the ground, and the water pump gonna be connected to 5 voltage and the ground, so it's gonna work. And when it get digital 0, the FET transistor gonna disconnect the wire, and the water pump will be not connected to a ground, so it will not work. And we have the capacitor before the water pump, as you see, so to prevent the noise.
In this slide we have the system flow. This is how our system works. So first, when we start, the system will ask us like manual mode, yes or no. Like if we say yes, we will go to the right side, which is the manual side, and it has 3 options. The first one is serial pump on, yes or no, and we have the serial pump off, yes or no, and we have the serial auto mode. If we said yes, we'll go over and start over there. And when we start over, the system will ask us again manual mode. No, we'll go down there, which is the automatic side, and it has 3 options. The first one will ask us like serial manual mode. If we said yes, we'll start over and go to the right side, and when we said no, we'll go down to the second option, slider value. It will check the slider value and save it. And then before the third option, we have the system will read the soil moisture and then compare the SD and the SR. SD is the desired soil moisture, and the SR the real soil moisture that we have. If the SD is more than the SR, the system the water pump will be off. The pump will be on, and if the SR is bigger than the SD, the pump will be on all the time. Will be off all the time, and then the system will read volt and power from the power analyzer and send the values to IoT server so we can read it in our application. And here's the mobile application, Blink GUI. As I explained before, it has like 3 gauges up there: the cell voltage and the power, the cell voltage, cell power, and soil moisture. The user can read there, and then we have the slider, and the user can set the soil moisture, and we have the 2 modes: automatic, and when we press the automatic it will turn to the manual mode, and then pump on or off. And we use like the blink because we can easily connect it to the ESP8266. That's why we choose like the blink. And then conclusion and benefits: monitor the soil moisture and just give the needed amount of water. Give a real feedback to the farmer regardless the distance. Reduce the cost on the farmer since the Wi-Fi is almost free. The education level of the farmer is not a matter since the system will use very easy to use application. The system can operate in manual or automatic mode. The farmer can start the irrigation to cool down the plant and avoid burning during the hot summer seasons. Future work: for better performance, the soil moisture sensor can be wireless sensor. In this case, more than one sensor can be spread all over the desired area. Solar tracker system can be upgraded to 2-axis tracking system instead of one tracking system as we have. So the 1-axis tracking system will move to 2 direction, left and side. But when we have the 2-axis, it will move to all the directions. This will harvest more power from sun energy. The land under irrigation can be divided into small zones, and each zone will irrigate it from separated water pump. Add a water level sensor to the water tank to give the user a clear vision about the remaining water quantity in his farm. The software can be upgraded to store the moisture value during one irrigation period, so the user can view the history for the best result.
And here we have the acknowledgements. We would like to take this opportunity to thank Dr. Dugda for guiding us to accomplish the goal of this project. We also thank our fellow students for the moral support and advices they have offered toward this project. And finally, ECE department chairman and faculty member. Thank you, guys. And we have here the demo.
So this is how the solar system works. So this is how the water pump work. It says automatic, and the moisture is 79, and if it's less than 30% the moisture soil, it will pump water. If it's more than 30%, it will not stop. Pump water, yeah. So it says 79, it will not work, and when you put it here, it says 0, and will turn the water will go through, and every 5 seconds it will be on. And we have another option, which is manual on, off. It will not work. On, it will work. So it says manual, off, and that's it. Thank you.
And thank you so much for watching, and have a good day.